Hello students, this is Dr. Siva Nagaraju from IARE. Today we are going to discuss some problems on multiplexing. So we know that multiplexing means we are going to combine more number of signals to transmit on a single channel. Okay, so we are going to do some problems on this multiplexing. So this multiplexing again come into the module 2 and module 3 is covered by CO3. So the CO3 states that outline the basic concepts of communication system, need of modulation and fundamental elements to realize amplitude modulation systems. Okay, so this course outcome which is related to the module 2. Okay, so problems on TDM. So TDM means time division multiplexing. Okay, so the first problem is two channels on with a bitrate of 190 kbps and another with a bitrate 180 kbps are to be multiplexed using pulse stuffing TDM with no synchronization bits. So here we are going to multiplexing two channels. Already we know that multiplexing means we are going to combining more channels. Okay, so here we are using only two channels and one channel with a bitrate of 190 kbps and another one is at a bitrate of 180 kbps. Okay, so here you can see the second one is less than the first one. Okay, so here which type of multiplexing is using? TDM, time division multiplexing. So what they ask, what is the size of the frame bits, size of the frame in a bits? What is the size of a frame in bits? That means the size of frame in bits. What is the frame rate? Second one is what is the frame rate? And third one, what is the duration of frame? And the fourth one is what is the data rate? So these are the four points they ask in the given question. Okay, so we are going to solve this problem. So we are going to add an extra bits to the second source. Why? The second source is 180 kbps. Okay, so to make both 120 kbps, when you are adding another bit to the second source, so it is going to get 120 kbps. Okay, so what are the first bit they ask? What is the size of a frame in bits? What is the size of a frame in bits? Okay, so here where the frame size is 1 plus 1. Okay, the frame size is 1 plus 1. So totally 2 bits in a frame. Okay, and second one is what is the frame rate? So here we are going to take the 120 kbps. Why? The second source also increase it to 190 kbps. So here the first one would consider as 190 kbps. 190 kbps. So 190 kbps means how many? What is the frame rate? So here what is the frame rate? So we're going to get the frame rate. So 190,000. So 1,90,000 frames per second. So this is the frame rate. So here you can see. And third one is what is the duration of a frame? So here we know that frame rate. So that is just inverse of this frame rate duration. Okay. So the third point is frame duration. So the frame duration is inverse of the frame rate. So what you got the frame rate? 1,90,000. 1,90,000. So by using calci, you are going to solve this. So 1 divided by 1,90,000, you get the 5.3 microsecond. So this is the frame duration. Okay. Now what is the data rate? So in the previous bits ask what is the frame, what is the size of frame, what is the frame rate, what is the duration of frame. But here they ask what is the data rate. Okay. So here the data rate we are going to calculate. So what is the frame rate? It is 1,90,000 into how many bits we are sending? 2 bits. So this is the data rate. So we are getting 3,80,000. So simply you can say that 380 kbps. Okay. So this is the data rate. So here the output bit rate is greater than the sum of the input bit rate. So what is the input bit rate? 370. Why? 190 plus 180, you got 370 kbps. But here the data rate is, output data rate is 380 kbps. So because of extra bits added to the second source. So that's why extra bit is going to add. Okay. So coming to the second problem. So the second problem is related to the FDM. As previously we were discussed on TDM. Now in FDM. So in FDM system, 24 channels are multiplexed, each channel having a bandwidth of 100 kHz if the guard band between the channels are 2 kHz. The minimum bandwidth required for transmission is. So what is the bandwidth required? So here we must require a formula. So what is the bandwidth formula for FDM? Okay, so here you got to write the first formula. Bandwidth is equal to number of channels into channel bandwidth plus number of channels minus 1 into guard band. Okay, into guard band. So this is the required formula for solving the problem. So here we know that how many channels are multiplexed. 24 channels are multiplexed here. So number of channels we know. Each channel having a bandwidth. So what is the channel bandwidth? 100 kHz. And in FDM we must require the guard band. Why? The channels is going to overlap. So to avoid the overlap, we must require a guard band between each channel. Okay. So that guard band is 2 kHz. So here we are going to substitute all these values in this formula. You are getting the minimum bandwidth required. Okay. So first we go for the given number of channels. So what is the number of channels? Is 24. Number of channels is 24. And channel bandwidth is 100 kilohertz. And guard band is 2 kilohertz. So this is given data. By using the given data, we are going to calculate the bandwidth. So what is the bandwidth formula? Number of channels. So number of channels is 24 into the channel bandwidth. So what is the channel bandwidth here? 100 kilohertz plus number of channels minus 1. So number of channels 24 minus 1 into guard band. So what is the guard band? 2. So all are kilohertz. So not required to write the kilohertz. Okay. So here 2400 plus here 24 minus 1, 23 into 2. So 23 into 2, 46. So by adding this, 2446 kilohertz. So this is the bandwidth. Okay. And coming to the next problem. So the next problem is, so here 4 channels, 2 with a bitrate of 200 kbps and 2 with a bitrate of 150 kbps are to be multiplexed. Okay, so here we are using multiple channels. So in the multiple we are having 4 channels. So out of 4, 2 with a bitrate of 200 kbps and 2 with a bitrate of 150 kbps are to be multiplexed using multiple slots TDM with no synchronization bits. So here 4 channels are going to multiplexed by using the TDM time division multiplex. So here what they ask, calculate the size of frame rate, duration of frame, data rate. But before solving this problem, they given some clue. Assume 4 bits from the first 2 sources and 3 bits from the second 2 sources. Okay, so first 2 sources, we are assuming 4 bits are coming, and again from the second source we are getting 3 bits. Okay, so they given the data. So this is the given data. By using this given data, we are going to calculate the size of frame rate, duration of frame, and data rate. Okay. So for the given problem, we are going to solve. So first, frame size. So frame size is 4 into 2 plus 3 into 2. Why? Here written like this, you go for this one. 4 bits from the first 2 sources and 3 bits from the second 2 sources. So that's why 4 into 2 plus 3 into 2. So we got 8 plus 6 gives 14 bits. So the frame consists of 14 bits. So that is the frame size. And second one, so each frame carries 4 bits. Each frame carries 4 bits from each 200 kbps. Why? Because the first one given has 200 kbps source and other is 150 kbps. That means the 4 bits from each 200 kbps and 3 bits from 150 kbps. Why? Because they given the problem. So here 200 kbps and 150 kbps. Okay. So from this we go to calculate the frame rate. So the frame rate is 200 kbps. This one divided by how many bits? 4 bits. And again in this source, again 150 kbps. So 150 kbps divided by how many bits? 3 bits. So what you got? 50,000, both 50,000 frames per second. So this is the frame rate. So one is 200 kbps and another is 150 kbps. Why? Because we are having totally 4 channels. Out of 4, 2 channels are with 200 kbps and other 2 channels are with 150 kbps. Okay. So in 200 kbps, 4 bits are transmitting. And again in 150 kbps 3 bits are transmitting. So this is the frame rate. Now another one is the frame duration. So this is the frame rate and this is the frame duration, that is 1 by frame rate. 1 by frame rate. So what is the frame rate? 50,000. Okay. So that is nothing but 20 microsecond. So this is the frame duration. And the last one is the output bit rate. So here we are going to calculate the output, data rate. So how much data is flowing. Okay. So 2 into 200 plus 2 into 150. Why? 2 channels are with 200 kbps and 2 channels are with 150 kbps. So totally here 2 into 200, 400 plus 300 gives 700 kbps. So this is the output data rate. So this much data is going to flowing. Okay. Yeah. Coming to another problem. 3 signals M1, M2 and M3 are multiplexed. M1, M2 have a 5 kHz bandwidth and M3 has a 10 kHz bandwidth. Design a commutator switching system so that each channel is sampled at its Nyquist rate. Okay. So this is the given problem. So here we are going to design commutator switching system. Okay. So you can see how many signals? 3 signals. M1. So M1 is 5 kHz. So the Nyquist rate. So Nyquist rate is Fs is equal to 2 FM. So that is 2 into 5, 10 kHz. So how many samples? 10,000 samples per second. Okay. And next one is M2. Why? Because here you go for M1, M2, M3. M1, M2 both having 5 kHz and M3 is 10 kHz. Okay. So that's why M1, M2, M3 we are taking the signals, 3 signals. So M2 also having 5 kHz. So the Nyquist rate is again 10 kHz. So 10 kHz is equal to 10,000 samples per second. And third one is 10 kHz. So what is the Nyquist rate? 2 into FM. So here we write Fs equal to 2 FM general. So 2 into 10, 20. So 20 kHz gives 20,000 samples per second. So now here we are going to design commutator. So what is the rate of the commutator we are going to design? So output rate of commutator. So we are going to add all these samples or Nyquist rate, whatever it may be. So here 10,000 plus 10,000 plus 20,000. So you got 40,000 samples per second. So this is the output rate of commutator. Okay. So this is the commutator. So this commutator is going to select for each time. So here previously we are going to calculate the 40,000 samples per second. This is the output rate of the commutator. Okay. So by using this, so here is given 40,000 samples per second. Okay. So here the speed 40,000 by 4. So you get the 10,000 rotations per second. So this is the design of the commutator. Okay. Coming to the another problem. So 4 messages band limited to W, 2W and 3W respectively are to be multiplexed using TDM. So here time division multiplexing is using. Find the minimum bandwidth required for transmission of this TDM signal. Okay. So 4 messages are bandwidth to W, W and 2W, 3W. So 4 given 1, 2, 3 and 4. So these 4 signals are going to multiplex. So what is the minimum bandwidth required? So here formula. What is the formula? Bandwidth. So what they ask here? What is the bandwidth required for transmission of the TDM signal? So the bandwidth is RB by 2. So RB is the bit rate. So how to calculate the bit rate? By this messages. So FS1, sampling frequency of the first one, sampling frequency of the second one, and sampling frequency of the third one, and again fourth one. So the bit rate is equal to FS1 plus FS2 plus FS3 plus FS4. Okay. So here they taken. So how we did FS? Nyquist rate or sampling frequency, that is equal to 2 FM. FS equal to 2 FM. So that is the Nyquist rate. So for the first signal 2 FM, again second 2 FM, third signal also 2 FM, fourth signal also 2 FM. But the first one is, first 2 are W. So W hedges. So that's why 2W plus 2W, and the third one is 2W is given. Okay, the signal is third signal is bandwidth to 2W. So here we are going to sampling frequency, again it goes to double. So 4W, and the third one is 3W. So that is goes to 6W. So totally the RB is 14W. Now what is the formula? Bandwidth is equal to RB by 2. So what you got RB? 14W. So 14W by 2 gives 7W. So this is the minimum bandwidth required for transmission of the TDM signal. So this is the problem to solve. Okay. Now coming to the another problem. So a multiplexer combines 3 20 kbps data channels using a time slot of 2 bits per slot. What is the frame rate, frame duration, data rate and slot duration? So here F by S is given 40K. Okay. So the given sampling frequency. Okay, sampling frequency is 40K the given. So these are the given data. Okay. So here first you go to calculate the data rate. Data rate is equal to, so data rate is equal to how many bits are sending? 3 to 200 kbps. So 3 into 200 kbps gives 600 kbps. So this is the data rate, 600 kbps. That means 600 kilobits per second is going to transmit it. Okay, that is the data rate. Now frame rate. So the frame rate is 600 kbps divided by 6 bpf gives 100 kbps. Why? Because here 3 channels. And how many bits per slot? 2. So 3 into 2 gives 6. Okay. So 6 bits per frame. 6 bits per frame. 6 BPF means bits per frame. So 600 kbps divided by 6 BPF gives 100 kbps. So that is the frame rate. Now frame duration. So frame duration is inverse of frame rate. That equal to 1 by 100 kbps. So by using calc, you are going to calculate the 1 by 100 kbps, it gives 25 microsecond. Okay. Coming to the slot duration. So the last one is slot duration. So here the slot duration is 25 microsecond divided by 3. Why? Why taking 25 microsecond? Here the frame duration is 25 microsecond. The frame duration is 25 microsecond. So here 3 bits, 3 channels are multiplexing. Okay. So this 25 microseconds divided by 3 channels. Okay. So here 3 indicates the channels. So 25 microseconds is the frame duration. So in this frame 3 channels are transmitting. Okay. So now what is the slot duration? So 25 microsecond divided by 3 gives 8.33 microsecond. Okay. So this is the one problem. Okay. Coming to the next problem. That is 7th one. A multiplexing system based on TDM is characterized by a frame composed of 10 time slots. In each time slot, 128 bits are transmitted. The system is used to multiplex 10 telephone channels, each of which has a transmission rate of 64 kbps. Okay. So this is the given problem. From this given problem, we are first taking the given data. From that given data, the sufficient formulas are used to solve this problem. Okay. So seeing this question is very large, but solution is very easy in this. So first take the transmission rate. The transmission rate of the multiplexer. So what the transmission rate here? 64 kbps. Okay. So 64 kbps into how many channels are going to multiplex here? 10 channels. Okay. So transmission rate of the multiplexer. Transmission rate of the multiplexer. So how to get the transmission multiplexer? Here the transmission of the multiplexer is 64 kbps into how many channels are used to multiplex? 10 channels. So 10 into 10 gives 640 kbps. So this is the transmission rate of the multiplexer. Okay. And another is the frame duration. So the frame duration is 128 kbps divided by 64 kbps. So once again you go to see. So here the frame duration, how many bits are transmitted? So here is 120 bits are transmitted. 120 bits are transmitted at a rate of 64 kbps. Okay. So here 128 divided by 64 kbps. So it gives 2 millisecond. So this is the frame duration. Why? Because here in denominator having kilobits per second. So this kilo goes to the numerator, it is going to milli. Okay, milliseconds. So this is the frame duration. The frame time is 2 milliseconds only. Okay. Yeah, coming to another problem. So here we're considering 24 voice signals are sampled uniformly and then time division multiplex. So here they given which type of multiplexing, time division multiplexing is used. The sampling operation uses flat top samples with 1 microsecond duration. The multiplexing operation includes provision for synchronization by adding an extra pulse of appropriate amplitude and 1 microsecond duration. The highest frequency component of each voice signal is 3.4 kHz. So this is a problem and given data. And what they ask here, assuming the sampling rate is 8 kHz, calculate the spacing between successive pulses of the multiplexer signal and assuming the use of Nyquist rate sampling. Okay, so this is the given data rate. So now we are going to solve this one. So what they are given sampling rate. So what the sampling rate here is 8 kHz. The sampling rate is 8 kHz. So that is 8,000 samples per second. So this is the sampling rate. Okay. So how many voice channels are used? They use 24 voice. Why? Because go for the question. So 24 voice. Okay. So 24 plus 1 synchronizing pulse. 24 plus 1 synchronizing pulse. Okay. And the pulse width of each voice channel and synchronizing the pulse is 1 microsecond. So this is the given data. 24 voice channels is given and 1 synchronizing channel is given. Okay. And so the pulse duration is given. Here the pulse duration is 1 microsecond is given. Okay. So now what is the time taken by the commutator for one rotation? Why? The commutator is just like it is moving in this way. So at what rate here the commutator is going to move? For example, here 24 like this. So they are going to set. So at what rate this commutator is moving? Okay. So the commutator, what is the time taken by the commutator for one rotation? So how do you get this one? This is taken from these samples. Okay. So here we would write time taken by the commutator for one rotation. For one rotation is equal to 1 by 8,000 gives 125 microsecond. So this is the time taken by the commutator for one rotation. Okay. And number of pulses produced in one rotation already given. That is nothing but 24 plus 1. So 25 pulses are produced for one rotation. Okay. And the leading edges, another one you go to correct. The leading edges of the pulses are, so 125 microsecond divided by this 25 channels. Why? Another one synchronized channel. 24 voice channels plus 1 synchronized. So 25. So totally how we got? 5 microseconds. This is a 5 microseconds. So this is the reading edge of the pulses is 5 microsecond. Now spacing between successive pulses. So spacing between successive pulses. So how to get these successive pulses? 5 minus 1. How many leading edge pulses? 5 micro. So this minus 1 you get 4 microseconds. So this is the spacing between successive pulses. So this is the first bit. Why? Because in this problem they given 2 bits. Coming to the second one. So here the Nyquist rate for sampling. Nyquist rate of sampling gives 2 into 3.4 kilohertz gives 6.8 kilohertz. 6.8 kilohertz. So that means how many samples? 6,800 samples are produced per second. Okay. So now what is the rotation time? Why the commutator here? This is a commutator. This commutator is going to select each channel like this. So what is the time taken for the commutator for one rotation? Okay. So how did you get this one? One rotation of commutator takes. So how much time taken for one rotation? That is 1 by 6,800. So you got 147 microsecond. So this is the commutator time for one rotation. Okay. So next, this 147 microseconds corresponds to 25 pulses. Why? Already in the first bit we taken 24 plus 1 synchronized. So 25 pulses. So what is for one pulse corresponds to how much time? So nothing but this 147 by 25. You are getting 5.88 microsecond. So this is 5.8 microsecond for one pulse. Okay. So this is the end of the second bit. So coming to the another problem, ninth problem. So what the ninth one says? 6 message signals, each of bandwidth 5 kHz or time division multiplexed and transmitted. Determine the signaling rate and the minimum channel bandwidth of the PAM TDM channel. Okay. So here the type of multiplexing is time division multiplexing. So how many signals are taken? Signals are channel ordered maybe 6. So each having the bandwidth 5 kHz. Okay. So first you go to write the given data. So how many channels? 6. So first the number of channels. The number of channels is 6. Number of channels is 6. So bandwidth of each channel. Bandwidth of each channel is 5 kilohertz. So here you can call as FM. Why? Each signal is band limited to some frequency given. Okay. So here each channel bandwidth is FM. So here you going to calculate what is the sampling frequency or minimum sampling rate. Why? Because they ask to determine the sampling rate. So sampling rate is nothing but F is equal to 2 FM. So 2 into 5 kilo. gives 10 kilohertz. 10 kilohertz. Okay. So this is the sampling. But they ask signaling rate. Okay. This is the sampling. Coming to the signaling rate. So signaling rate. Signaling rate is number of bits per second. Number of bits per second. So how many bits? So here 6 channels into what is the sampling? 10 kilo. Okay. So here the signal means how to get number of bits per second. So number of channels and at what sampling frequency. Okay. So 6 into 10 kilo bits. Okay. So here you can write 60 kbps, 60 kilobits per second. So that is the signaling rate. So 60 kilobits are transmitting per each second. Okay. Next one is minimum channel bandwidth. Minimum channel bandwidth. So what is the minimum channel bandwidth? So the formula is bandwidth is equal to N into FM. N into FM. Already the FM is given. FM is a signal bandwidth. Okay, each channel bandwidth. So how many channels? Here 6 channels. So what is the FM? 5 kilo. So that is 30 kilohertz. Okay. Minimum channel bandwidth is 30 kilohertz. Okay. Next one is sketch a channel interleaving scheme for the time division multiplexing of the following PAM signals. 4 kHz. 4 kHz telephone channels and 120 kHz music channel. That means here 6 channels. One is 5 telephone channels and one is 1 music channel. So these 6 channels are going to multiplex using the TDM. Find the pulse separation rate of the multiplex signal and estimate the minimum system bandwidth required. Okay. So for this problem, you go to sketch the channel interleaving scheme. Okay. That means the block diagram required for this PAM signal. Okay. So the first bit is each telephone channel of bandwidth 4 kHz must be sampled at Nyquist rate. So each telephone channel of bandwidth 4 kHz must be sampled at Nyquist rate. So what is the Nyquist rate? 2 into 4. That means F is equal to FM. It is 8 kilohertz. 8 kilohertz. And second one, the 20 kilohertz music channel must be sampled. Why? Because when you are going to transmit, each channel is going to sample. Before going to multiplex, the sampling is required. So for the 20 kHz music channel, sampling is Fs is equal to 2FM, that is 20 gives 40 kilohertz. Okay. So the samples are required 2 to 4 bit. 2 to 4 bit AD converters, ADC, analog to digital converters, the equivalent digital signal. Why? This is TDM. TDM is time division multiplexing. It is used for the digital signals. So here the telephone channels and music channel are in analog form. So convert this analog into digital form. So here ADC converters are required. So how many ADC required? 2 4-bit ADCs are required. 2 4-bit ADC. Okay. So these signals are finally multiplexed. Okay. So this is the way. And another one is the commutator. So what is the commutator? Why? Because here my channels are five telephone channels are there. From the 5 telephone channels, I'm taking the signal. So at what moment is going, at what time the commutator is moving from one channel to another, and what is the time required for one rotation for the commutator. So that's all required. Okay. So here the TDM commutator output has a pulse repetition rate of 40 kbps as the 5 channels of 8 kHz sampling rate. Okay. So the pulse repetition rate is also required, that is 160 given. So 160 plus 160 gives 320. Okay. So before going to this one, you go to sketch this interleaving system, then you got some idea. Okay. So first you are going to 4-bit ADC. Why? How many required? 2 4 ADC already 2 written. Okay. So this is a sampler. And here we are giving 20 kHz music channel. So this is simply one music channel is coming to the sampler and is going to sample at the rate of fs 40 kHz, and this 40 kHz signal is applied to the ADC. Okay, this is over. Now here we are going to take the commutator. So how many? 5. 1 2 3 4 5, like that. Like that. Okay. So all are 4 kHz channels. This 4 kHz, this 4 kHz, and this also 4 kHz. Okay. So these are the 5 telephone channels. So 5 telephone channels and 1 music channel. So these 6 channels are going to multiplex. So how to multiplex? First you go to convert into sample by using the sampling frequency or sampling rate. F is equal to Fm. Okay. So the commutator, this is a TDM commutator which can be moved at a rate of 40k samples per second. Why? Because here it is 8, 5 8s are 40. Okay. So here we are going to sample this 4 kHz. This is a FM. FM value is 4 kHz. Fs equal to 8 kHz. So how many channels? 5 channels. So 8 5s are 40. Okay. So this 40 k samples per second, that is a commutator. Okay. So 40 into 4. So how many here getting? 160 samples. 160k. 160k samples. So yes or no? Here 40k is applied to the 4-bit ADC. So the output is 160 kilo samples per second. Okay, and next from here, this also FS is 40k. So this is also 40k. So again 40k into 4 bit. So this also 160k samples per second. Okay. So these two 160s is going to apply to a mux multiplexer. Mux means multiplexer. So these two is going to multiplex and form into a 320k. 320k. Okay. So the minimum bandwidth required, okay, is 320 kilohertz. The minimum bandwidth. So the minimum bandwidth required. The minimum bandwidth required is bit rate. Is nothing but bit rate. So what is the bit rate? 320 kilohertz. Okay. So this is the given problem. So why? Because in this problem they ask us sketch the system, interviewing system. So what they given? 5 telephone channels and 1 music channel is going to multiplex. Okay. So here each channel having 4 kilohertz. So 5 into 8. Why? Because here the sampling is Fs is equal to 2 FM. So 2 into 4, 8 kilo. Okay. So each channel is sampled at a rate of 8 kilohertz. So how many? 5 channels. So this 8 into 5 gives 40 kilohertz. Okay. That's it. That is the sampling. So this is going to apply to the commutator. So this is the commutator. In this picture, the left hand side, the arrow is indicating the commutator is moving from one channel to another channel. So at the rate of 40k samples, 40 kilo samples per second. And this is going to apply to the ADC, analog to digital converter. Okay. So it is a 4 bit. So 4 into 40. 4 into 40 gives 160 kilo samples per second. So this is the upper part, and here in this lower part another channel is there, that is the music channel. So the music channel is 20 kilohertz. So here also you got to sample. Fs is equal to 2 FM, that equal to 2 into 20 kilohertz gives 40 kilo. So this 40 kilohertz sample frequency is applied to the 4 bit ADC. So 4 into 40 kilo gives 160 kilo. So these two 160 kilo sample is applied to the mux multiplexer. Okay. So finally we are getting 320 kilohertz. Okay. So this is the problem. Okay. So the references are taken from these problems are taken from Simon Hakin and Sanjay Sharma and Chakrabarti. So different textbooks were considered for forming the problems. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.